Hello, we are Juan Carlos Vadillo, Anayana Ramos, and Bruno Cunha, and together we work on a weather prediction for wine industry. The goal of this project is to predict the weather in a long term with the help of machine learning and artificial intelligence, therefore help wine producers that use Pinot Noir grape to prepare themselves for upcoming decisions. Pinot Noir is considered by experts as the most difficult grape variety to grow and is extremely fussy regarding the weather. It needs an average grown season temperature that stays between the 13 and 18 degrees. Most of the most expensive wines are made of Pinot Noir. This table shows the top 10. Burgundy is the home of the grape, is its birthplace, and the first records date from 1375. Yarra Valley is famous to produce high-quality Pinot Noirs in the New World, wines that are coming out of Europe. The technology that we're going to use to build this machine learning module is Python, due to its powerful libraries and open source technology. For reasons of time frame given and data availability, the scope of this project will be limited to the temperature factor. We start first reading our database. Then we rename the columns for better understanding and easy way to work with the dataset. The model that we tend to use is ARIMA. It needs a date-time format. And as we want to predict the average season grown temperature, we need to create an average temperature column. We group by month and year and indexing the date given a month frequency. So the ARIMA model works better. ARIMA needs an stationarity kind of dataset. This means that sustains the same behavior in a period of time. The plot proves the concept. Also, we can use the moving average or rolling mean. For this, we create the following function. Another tool to prove stationarity is the ADF. We need a p-value lower than 0.05. This is the proof of concept. P-value is 0.021, and the moving average stays during the frame time. We can plot an autocorrelation and then we select the model. After, make sure that our data is a stationarity. After that, we split the data into train and test set. Auto-ARIMA function will provide the values of RI and MA, which can be commonly interpreted as P, D, and Q. Then we create our ARIMA model, providing the values of the auto-ARIMA function give us. Now we can see how the results fit in the values of the training set. As a result, we have the mean square error, which is the sum of a square's distance between the target variable and the predicted variables. In this case, it's 3.50. Now we predict or model and compare against the test set. The plot proves the concept. The test average temperature is 10.87 degrees, whereas the predict average temperature is 10.12. Now we analyze the accuracy. Our ARIMA model works with an MAPE, which stands for mean absolute percentage error of 31.67%. That means that the predict values have a 31.67% of error over the test values. Now, for predict future values in the future, let's say 2031, we want to predict the average season grade temperature. So we drop the following months. Now we compare with the year 2000, which was considered one of the best years for the Pinot Noir production in Burgundy. And we plot the results using a blocks plot showing the mean, the max values, and the mean values for both. Now we're going to working with the Yarra Valley weather dataset. Please, some steps and concepts will be repeated. Therefore, just important changes will be outlined. For further information, please look at the documentation provided. We can see here that we also have a stationarity. Our p-value stands below 0.05. The value of this p-value is 0.04. And we have our autocorrelations and partial autocorrelations plots. In this case, ARIMA suggests order values of 0 or 501, for fitting our model. This probably is because of some difference in the behavior of the data in the period of time given. Now, we fit the model against the real average temperature. In this case, we can see that the mean square error is lower. That might suggest a better fitting. Now we do our predicted model again, and we plot it. In this case, the average temperature of the test is 14.46, and the prediction average temperature is 13.71. Now analyzing the accuracy, mean that the absolute percentage error is 8.1%. This means that apparently there was less errors on these predictions. Now, please know one thing. These models, even for a 0.1 degree difference, will consider as an error. These are just some sort of ways to predict the accuracy of the model, but they don't necessarily mean that one is better than the other. Now we plot again our results. Again, we compare with the 2000 year of Burgundy and the 2031 of Yarra Valley. ARIMA conclusions, pros and cons. After performing ARIMA model both in Burgundy and Yarra Valley datasets, we can say the following. According to the ARIMA predictions, both regions will still have the weather needed during the respective average season grade temperature for keeping producing Pinot Noir wines. ARIMA seems not to be only very susceptible to seasonal data, but also some high random peaks when the model was applied in the Burgundy dataset, causing the MAPE increase the error on 31.67%. One con of ARIMA is that it requires no less than 100 observations. For ARIMA forecasting, time series and data time indexing is a must. ARIMA apparently seems to struggle in terms of accuracy for longer period of times. It performs better for short-term scenarios. We also work with two other models, random forest with a maximum depth of 10 and linear regression. With these models, we compare the actual value with the prediction value and calculate the difference or the error per se. For example, in the random forest, we have that in the date 1st of May of 2017, the actual value was 11.8 degrees and the prediction mark 12. Linear regression in same date predict an actual value for the same date 11.8 and the prediction was 11.9, closer than in the random forest. Due to the time given for the presentation of this project, if you want further information of how this model were deployed and worked, have a look please on the documentation and on the links provided where the deploy has been stored. According to ARIMA model predictions and based on the data that we input to them, it will be continued to be possible to keep growing the peanut novel grape with optimal conditions, temperature, and therefore keep producing high and premium quality wines made of the mentioned grape. The average season growing temperature in both regions in the year 31 have been marked as around 14.52 degrees Celsius for Burgundy dataset with an MAPA of 31% and for Yarra Valley with a MAPE MAPE of 8.1%. Thank you so much.